Have you ever stopped to think, really think, what it'd be like navigating your own neighborhood if, say, the sidewalks weren't usable or the curb ramps weren't there? For millions of people, that's not just a thought experiment. It's their daily reality. Making sure everything is accessible is this huge, often overlooked challenge. It's all governed by something called ADA compliance. But here's the thing, and this is what's really exciting, this whole complex world. It's being totally transformed by some really cutting-edge technology. So today, that's what we're doing, a deep dive into exactly that. We've pulled together insights from a fantastic recent webinar, had experts from, let's see, the GIS Certification Institute, Bad Elf Engineering Mapping Solutions, or EMS DeepWalk Research, and Next Level Services. These are the folks really innovating, Right on the front lines. Our mission today is to sort of cut through all the jargon, the complexity, and give you a clear, hopefully engaging overview. We'll look at how GIS, that's Geographic Information Systems, and related tech are just revolutionizing AD compliance reporting and how we manage infrastructure.
Get ready for some, I think, pretty surprising facts and insights that should leave you feeling, well, pretty well informed on this really critical topic. Okay, so let's unpack this a bit. At its heart, we're talking about the Americans with Disabilities Act, ADA, from 1990. Its core purpose really is civil rights, safeguarding those rights and mandating accessible infrastructure, like sidewalks, curb ramps, things like that, for everyone in the U.S. Now, other countries have their own standards, sure, but ADA is specifically U.S. law.
Yeah, and what's really fascinating, or maybe impactful is a better word, is the enforcement behind it. You've got the U.S. Department of Justice, the DOJ under Title II, that's for public entities, and the Department of Transportation, the DOT. They oversee these rules.
Right. So it's got teeth.
It absolutely does. I mean, this isn't just a recommendation. If a public entity, like a city or county, doesn't have an ADA transition plan or just fails to comply, well, the consequences can be pretty severe.
Like what, for instance?
We're talking loss of federal funding, for highways, other big projects. That's a huge hit.
Wow. Okay.
And then there's the lawsuits. From citizens, sure, but also directly from the DOJ. They have initiatives like Project Civic Access specifically for this. So, yeah, real teeth.
And the sheer scale of what needs to be compliant. It's massive, isn't it?
Oh, it's immense. Think about it. The U.S. has roughly, 4 million centerline miles of road?
4 million?
Yeah. And estimates suggest maybe 40 to 60% of those roads have sidewalks.
Okay.
Do the math. That's somewhere between 2 and 5 million miles of sidewalk across the country.
Million miles.
Every single mile has to be mapped, inventoried, checked for ADA compliance. It's just a staggering amount of infrastructure.
And it's not just about knowing where the sidewalk is, right? The compliance part is complicated.
Exactly. Yeah. That's the crux of the challenge. It's way more intricate than just, putting a line on a map. Compliance demands incredibly precise measurements, really specific numbers.
Like what kind of numbers?
Things like running slope, that's the slope in the direction you walk, and cross slope perpendicular to that. Cross slope, for example, typically has to be under a 2% grade. That's quite flat.
2%, wow.
Yeah, and widths of sidewalks, paths of travel, even things like the pressure needed to activate a push-button crosswalk signal. These are, as the webinar folks said, hard numbers to reach, fractions of a percent matter.
Which must have made the old ways of doing this pretty painful.
Oh, absolutely. Think about the traditional methods. It was all manual.
Like literally levels and measuring tapes. Pretty much. Literal levels, measuring wheels clicking along the sidewalk, people writing things down on paper forms. It was slow, labor-intensive, and honestly, awfully inconsistent.
Right.
There was this one study mentioned, I think it was Oregon DOT related, that really highlighted it. They took a digital level, right? Had 10 different people use it 10 times each on the exact same sidewalk panel.
Yeah.
10 different results every time. It just shows the inherent variability, the lack of repeatability.
So that brings up a key point you hear a lot in this field, accuracy. But there are different kinds.
Yeah, exactly.
Yeah.
That's crucial. We need to distinguish between two things. First, there's absolute accuracy. That's basically, where is this thing on planet Earth? How accurate is its position on the map?
Got it. Location.
Right. Then there's relative accuracy, or you could call it precision or repeatability. That's about the consistency of the measurement itself. How reliably can you measure that 2% slope again and again? Is the data repeatable?
Okay, that makes sense.
And the best solutions, the ones we're starting to see now, they nail both. High absolute accuracy, the curb ramp is where the map says it is, and high relative accuracy, the measurements of that ramp are consistent and precise.
All right, so this is where the technology comes in and really starts to change the game. GIS, powered by things like high-accuracy GPS.
Exactly. High-accuracy GNSS, Global Navigation Satellite Systems, which most people just call GPS. That's the foundation. And the big shift really is accessibility and affordability. Companies like Bad Elf were highlighted.
What do they do?
They make these very accurate but also relatively affordable GPS units. They connect via Bluetooth to devices people already have: smartphones, tablets, iOS, Android, Windows.
Bring your own device idea, BYOD.
Precisely. So you're not buying a whole dedicated, super expensive system. They mentioned the Bad Elf Flex Mini Extreme gets you 2-centimeter accuracy, or even better, for around $1,500.
2 centimeters. That's incredible for that price point.
It really is. It democratizes high accuracy, makes it feasible for cities, counties, consultants who couldn't afford the older, bulkier gear. They're S3 partners on GSA schedules, so they're integrated into the ecosystem.
So with that accessible accuracy, you then get these smarter workflows, like the approach from Engineering Mapping Solutions, EMS. Their ideas move the heavy lifting to the office.
Yeah, it's a really interesting paradigm shift. The idea is, let's make field collection as efficient as possible. Collect the raw data quickly. You might not need your highest paid, most specialized surveyor out there for every single foot of sidewalk.
Okay.
Then you take that raw data back to the office, and that's where the complex analysis happens. The detailed measurements, checking against standards, all that.
It's more cost-effective.
Potentially, yes. It optimizes how you use your personnel and resources. Less time spent on complex calculations in the field means faster data capture overall.
And they're using some pretty common tech to do this field capture, right? Not just specialized survey gear.
Absolutely. That's the clever part. They leverage consumer tech, like using iPhones, specifically the ones with LiDAR sensors, to capture 3D point clouds of the environment.
A phone in your pocket has LiDAR now. Amazing.
Right. And high-resolution GoPro 360 cameras, too, capturing everything around them. It's a smart mix.
And they even built this custom bike, the bike rack.
Yeah, the bike rack. It sounds cool, right? It's essentially an e-bike kitted out with a Bad Elf Flex unit for that high-accuracy GPS and a GoPro 360 camera.
What can that setup do?
It's built for efficiency on linear assets like sidewalks. It's maybe 8 to 10 hours of range on the battery. It's capturing data with sub-centimeter accuracy.
Sub-centimeter on a bike?
Yep. And they estimated it collects something like 80 high-accuracy GPS survey points per hour, so it covers ground quickly and accurately.
Okay, so you've got the bike, the iPhone scans, the 360 photos, tons of raw data. How does it all get processed back in the office?
They use a combination of software tools, some free, some custom. There's an app called Scanverse. It's a free iPhone app that uses the LiDAR to create those 3D models. Then for processing the point clouds, they use Cloud Compare. That's a powerful open source tool, really popular in the 3D data world.
Open source, nice.
Yeah. And finally, QGIS, another open source GIS platform, often with custom Python tools they've developed for the specific ADA analysis. The key is, measurements taken from these detailed 3D point clouds can then cross-verify the field data. You get this really robust, highly accurate picture.
And the 360-degree photos, are they just for context, or is there more to it?
Oh, much more. Those GoPro images are geotiffs, meaning they have geographic data embedded right in the file, metadata, like the camera model, date, time, importantly, the camera's orientation, and GPS coordinates.
Okay.
And here's the really neat trick. If you synchronize the camera's clock, the UTC time, precisely with the Bad Elf GPS unit's clock, you can pinpoint the location of each photo with centimeter accuracy.
So you know exactly where that photo was taken from.
Exactly, which lets you create these interactive panoramic views, kind of like Google Street View, but with your own current high accuracy data. You can do detailed assessments remotely. They even mention using it for things like mapping cemetery plots, integrated with Esri's oriented imagery tools. Super versatile.
Right, so we have these amazing tools for collecting incredibly detailed, accurate data.
Yeah.
Bad Elf, EMS. But then how do you actually turn all that data into, a plan, into work orders, fixes?
That's the next piece of the puzzle, and it's a huge challenge traditionally. That's where DeepWalk Research comes in.
Okay, what's their focus?
Their whole goal is to make ADA compliance simpler and more actionable for the end users. The municipalities, universities, state DOTs, and the consultants working for them. The big disconnect they target is moving from that collected data, whether it's digital checklists or even older paper forms, to an actual program, a curb ramp retrofit program or a schedule for fixing trip hazards.
Right, you collect the data, but then...
What? Exactly. Often, organizations would find they had to go back out and collect more data or remeasure things just to figure out how to implement the fixes. DeepWalk aims to bridge that gap.
How do they do it? with a mobile app?
Primarily, yes. Their mobile app uses the 3D scanners built into iPhones, the LiDAR again, to scan sidewalks and curb ramps. It creates these 3D models right there, and the system automatically analyzes them.
Checks for what?
The key ADA stuff, running slopes, cross slopes, widths, ramp areas, even identifies areas of deterioration. It also uses machine learning to automatically cut out individual sidewalk panels, identify panel types, figure out the path of travel, locate those detectable warning surfaces.
Wow, machine learning too. That sounds powerful.
It makes the data much more granular and immediately useful for planning.
And is it fast to use in the field? Easy to learn?
That's the goal. They talked about users achieving about 1.5 miles per person per hour.
Pretty good clip.
Yeah. And minimal training needed, like a 20-minute online course. They mentioned a lot of their clients use interns for the data collection, which speaks to its ease of use.
And then all that data goes somewhere accessible.
Right. It feeds into a web application. So managers, engineers, planners can log in, see the status, track progress, filter the data, and actually create programs and work orders.
You mentioned GIS earlier. How does DeepWalk fit in with tools like ArcGIS that many cities already use?
Seamlessly. That was a big point. They have really robust ArcGIS integration. With basically one click, you can copy all the collected DeepWalk data, the scans, the measurements, the compliance status, directly into your ArcGIS online account.
That's ready to use.
Pre-formatted, symbolized, everything. Ready to go. That's a huge advantage for organizations already invested in the Esri ecosystem.
Makes sense why they'd see good adoption then.
Yeah, they mentioned being used by over 90 municipalities now, all sizes. From tiny towns, one example was a place with only half a mile of sidewalk, population 400, all the way up to large state agencies like the Louisiana Department of Transportation.
Can you share an example? Like that small town, how do they use it?
Sure. They talked about Genoa, Illinois, a smaller community, no dedicated GIS staff. They use DeepWalk for their annual programs, identifying trip hazards that need grinding or removal, planning which sidewalk sections need full replacement, even tracking where vegetation needs cutting back from the sidewalk.
So they can filter by how bad the hazard is.
Exactly. Filter by severity, generate work orders, export lists, or maps for the public works crews. It shows these tools aren't just for big cities with huge GIS departments.
And DeepWalk keeps adding features. Something about curb ramp retrofits.
Yeah, they have a new feature specifically for planning curb ramp retrofits. It lets engineers visually inspect the slopes on each part of the ramp model, use their judgment, and easily add that ramp to a retrofit project list.
That seems really practical.
And communities like Genoa are using the data for transparency too, putting maps and progress reports generated from DeepWalk on their public website.
Oh, nice. So citizens can see the work being done.
Right. And it also demonstrates compliance efforts to the DOJ, shows they have a plan and are actively working on it.
What about the cost? Is this technology affordable for smaller places like Genoa?
They offer different models. There's a subscription model, like a package for, say, 25 miles of inspection per year, which might be around $12,000, including the web platform access. Or they do a per mile model, maybe $200 to $500 per mile for combined sidewalk and curb ramp inspection. Costs tend to go down for larger projects or if you're just doing mid-block sidewalks, for example.
Okay.
And importantly, they also offer rental programs for the iPhones and the Bad Elf GPS units.
Why is that important?
Because sometimes the iPhone's built-in GPS isn't accurate enough, especially in dense urban areas with tall buildings or urban canyons or under heavy tree canopy. So renting the high-accuracy Bad Elf unit ensures good data quality everywhere.
Got it. So we've covered the rules, the data collection tech, the planning software. Now, what about actually fixing the problems? The implementation. We heard from Jerry Tippman at Next Level Services. They're a concrete leveling company, right?
Yeah.
Doing the actual repairs.
Exactly. This is where, as you said, the rubber meets the road, or maybe the foam meets the concrete in their case. They specialize in fixing ADA issues, trip hazards, grinding concrete, foam jacking, mud jacking.
And they embrace this technology too.
Yeah, Jerry's story was interesting. He described their company initially as technologically impaired, his word.
Okay.
But they saw the need and adopted the Bad Elf GIS system for mapping issues. He gave a great example, an HOA project in the Arlington edition. They went out and mapped 860 distinct trip hazards with exact GPS locations for each one.
860. Precise.
Very precise.
Yeah.
And that was crucial because other contractors bidding on the job had wildly different numbers. One said 100 hazards, another said maybe 2,000.
Huge difference. How could the HOA even budget?
They couldn't, reliably. But with Next Level's accurate map and count, the HOA could finally get a realistic budget and break the project into manageable phases over 5 years.
That accurate mapping must really help with visualizing the work, too.
Absolutely. They use tools like Google Earth to overlay the data. They can show the client exactly which spots need repair, which ones need grinding versus lifting, which areas have already been completed. Jerry mentioned a specific area, Rocket Hill, where they could visually show the client exactly where work was planned and completed. It makes communication so much clearer for everyone.
What are the common ADA problems they're mapping and fixing day to day?
Well, trip hazards are a big one, usually defined as a 1/4 inch vertical difference or maybe 1/2 inch if the edge is beveled. Those strict 2% cross-slope requirements we talked about, they deal with fixing those. And another common issue is problems with the truncated dome mats, those bumpy warning surfaces at curb ramps. Sometimes improper concrete curing around them causes them to fail prematurely, so they map those for replacement.
It sounds like the biggest benefit, maybe, is just better communication across the board.
It really seems to be a game changer in that regard. Jerry emphasized how this mapping software eliminates miscommunication. Think about all the people involved. The field crews doing the work, the estimators pricing the job, the customer or HOA board, individual residents, different city departments.
Right, everyone needs to be on the same page.
Exactly. He mentioned Fort Wayne, Indiana, where multiple city departments use the system right of way. Streets, bridges, schools, parks. Instead of just giving an address like fix the sidewalk at 123 Main Street, they have a precise mapped point showing the exact location of the hazard. No more confusion. And Jerry made a really powerful practical point about cost, too.
Which was?
He basically said, look, it's a lot cheaper to do it before someone trips, falls, gets hurt, and you end up with a settlement or a lawsuit.
Proactive versus reactive.
Precisely. Identifying and fixing these issues proactively using these systems saves money and, crucially, reduces liability compared to just waiting for something bad to happen.
That makes perfect sense. Let's circle back quickly to that scientific evidence you mentioned earlier, the Oregon DOT, Oregon State study about manual measurements.
Right. That study really quantified the problem with the old methods. It found that when people use digital levels to measure slopes manually, the standard deviation, the amount of variation was significant, like 0.56% up to over 1% variation on slopes.
Which is huge when the standard is 2%, right?
Exactly. If your measurement tool itself has a potential error close to the tolerance you're trying to meet, your data isn't reliable. It really underscores why those manual methods were problematic.
And why these new technologies are genuinely superior.
Yes. High accuracy GNSS and these reality capture methods, scanning, photogrammetry, they are inherently, fundamentally more repeatable than people. Now, using just GPS to get millimeter-level slope readings directly on a sidewalk can be tricky, maybe even dangerous, depending on the setup. But coupling that high-accuracy GPS position with scanning devices, like the iPhone LiDAR or dedicated spanners, that seems to be the sweet spot. You get the necessary accuracy safely and efficiently. The technology just delivers more consistent results.
It also feels like a key theme emerging from all these examples, EMS, DeepWalk, Next Level, is collaboration.
Definitely. You see these specialized companies working together. Each one is kind of staying in their lane, focusing on their core expertise, whether it's affordable GPS, efficient data collection workflows, user-friendly analysis software, or the actual concrete repair.
But they combine their strengths.
Right. They combine those strengths to offer more comprehensive end-to-end solutions for the client. It's not one company trying to do everything anymore.
And touching on cost one last time, it seems like these tech solutions are proving their value.
I think so. While costs obviously vary depending on the project scope and specific tools, the example suggests that solutions like DeepWalk's $200 to $500 per mile range are becoming cost competitive, if not cheaper, than purely manual methods, especially when you factor in the improved accuracy and efficiency. Even companies like Next Level, who were initially hesitant, found the investment worthwhile because it led to better data, clear communication, and ultimately more effective project execution. The trend is definitely towards better data for the money.
Okay, wow. What a journey we've taken here in this deep dive. We started with understanding just how big and complex the ADA compliance challenge is. Millions of miles of infrastructure needing precise assessment. Then we explored these really revolutionary geospatial tools, changing the game, affordable high-accuracy GPS, smartphone LiDAR, clever setups like e-bikes with scanners. And finally, we saw how all this technology translates into practical, actionable programs and actual real-world improvements on the ground, fixing hazards and making communities more accessible.
It really does make you think, though. When you consider that massive scale, those 2 to 5 million miles of sidewalk just in the U.S., and you see how efficient and accurate these new GIS-powered technologies are becoming, it raises a big question, doesn't it? How might this whole digital transformation reshape not just ADA compliance, but maybe the entire way we approach urban planning, infrastructure maintenance, even public safety in our communities going forward? What are the broader implications?
That's a fascinating thought to end on. What else could this level of detailed, actionable data unlock for managing our shared spaces? Something for all of us to think about. Thank you so much for joining us on this deep dive today.